Okay guys, so we're going to finish up section 2.4. Now 2.4, this is in section 2.4, okay? 2.4 is writing equations of lines, but we're going to talk about what's called direct and inverse variation, okay? Frequently seen on the MCAS test, so what's important? So that's why we go over it, okay? So direct variation refers to a pair of variables pair of variables refers to a pair of variables, hold on here, related by a constant of variation, okay? So I think these notes are going to be much better than what they give you in the book. In the book, they give you something really short, and I don't think it's very effective, to be honest with you. So I think it's helpful to have these down. So when they say that they vary directly, okay, direct variation, vary directly, refers to a pair of variables related by a constant. So they would say something like this: y equals k times x. And what happens with direct variation, the formula for direct variation is x over y equals x over y, okay? And the way that I want you to remember this is if x goes up, y goes up. If x goes down, y goes down. Okay? So as x goes up, y goes up. As x goes down, y goes down. Directly related. They are directly related. As one goes up, the other goes up. As one goes down, the other goes down. Okay? Here's the formula that you have for those. That's the formula that you use to set these up. Now, examples of these. Examples. One example would be working wages. Okay? So like dollars per hour. Okay? So we'll say here is hours and here is dollars. And if you work 5 hours and you make $60, if I work 10 hours, I make $120, okay? As my hours go up, my pay goes up. In this case, I'm making $12 per hour. So 12 would be the constant, okay? My equation would be y equals 12 times x, where x is hours and y is your pay. If I had area, okay, area of a circle, area of a circle, okay, and the radius. These two things are directly related. As the radius goes up, the area goes up. If the radius goes down, the area goes down. Okay, so another pair of variables that are directly related, which is why we describe it with what's called direct variation. Okay? The best example that I can give you is working wages, how people get paid. Okay? A lot of people will get paid with dollars per hour. As your hours go up, your pay goes up. Okay? As the next week you work fewer hours, then you get less pay. Okay? So let's look at an example. Whoa, I almost lost it. If you earn, this is an old sheet now, $32 for working 4 hours, how much will you earn for working 12 hours? Okay? So, when you're doing a problem like this, you want to think of the formula. Okay? You want to think of the formula. And you have to let one of the variables be a letter. Okay? So the two variables we have here are hours and money. Let's let hours be x and let's let money be y. So my formula is x over y equals x over y. When it's direct variation, you put one variable directly over the other. That's one way to remember your formula. Okay? So let's take a look at this now. We said x was hours, so when you work 4 hours, you make $32. And they want to know how much you make if you work 12 hours. Okay? So there's a couple ways that you can do this. One way is you can say 4 times what is 12? 4 times 3. 32 times 3 is 96. So you can say x equals $96. The other way that you could have done that, sometimes this number doesn't divide evenly into that number. So what will always work is cross multiplying. This times this equals this times this. 4 times x equals 12 times 32. I'm not that good. I need to do that on a calculator. Twelve times 32. 12 times 32 equals 384. And then if I divide by 4 and I divide by 4, I get x equals $96. Okay? That is what's called direct variation. Direct variation. I'm going to give you guys one example to do. I'll leave the formula up. Assume x varies directly as y. If x equals 5, when y equals 12, find y. When x equals 15, go. Okay, so x varies directly as y. So I make x over y equal to x over y. It says x is 5 when y is 12, x is 5 when y is 12. Find y when x is 15. So again, 5 times what is 15? 3. 12 times 3 is 36. So y equals 36. Okay, hopefully you got it. So, inverse variation. This is the other half of what we're talking about. The other half, okay? Inverse variation. So when you have something that is inversely related, inverse variation, it refers to two variables that are inversely proportional to each other. What does that mean? It is very different than direct variation. Direct variation, as one goes up, the other goes up. As one goes down, the other goes down. But in inverse variation, as one variable goes up, the other goes down. That's what it means to be inverse. Inverse is kind of like opposite. Okay, they're kind of opposites. As one goes up, the other goes down. As one goes down, the other goes up. Okay, they kind of balance each other out. The formula for this, okay, the formula for inverse variation is xy equals xy. X times y equals x times y. Okay? So to show this, I'm going to do an example. Okay? Let's see. You have a 120-mile trip. Okay, 120-mile trip. Okay, and I'm going to go I'm going to travel 60 miles per hour. Okay? How long will it take for me to get there? Okay, so this isn't the inverse variation stuff yet, but this is just going to get us started with this, okay? So if I go 60 miles per hour, so up top here, I'm going to put my speed, and then here is going to be my time. Now we're talking about distance equals rate times time. So the formula that I'm using for this problem is d equals r times t. Well, my 120 mile distance, and my rate is 60 times t, so we know that 60 times t equals 120, t equals 2. So if I go 60 miles per hour, my time is 2 hours. It takes me 2 hours to get there. Okay? So let's say that Mr. V, okay, Mr. V's going. He's going to take the back roads. Mr. V likes to go in the back roads and see the, largest ball of yarn in West Dartmouth and all that kind of stuff. He's interested in a lot of different things. Okay? Very interesting guy. So, Mr. V goes 30 miles per hour. Okay? So if he goes 30 miles per hour, how long is it going to take him to get there? Well, we could do it with our formula, xy equals xy. We could say that 60 times 2 is equal to 30 times we don't know. Okay? We don't know what that is. Okay, so 60 times 2 is still my 120, and that's equal to 30 times 4. So if he goes 30 miles per hour, it's going to take him 4 hours. So as his speed went down, his time went up. Okay? And then you get Mr. Target, who, he's got to get there. He's got to get there, but he doesn't want to go too fast. So he said, I'm going to go 40 miles per hour. Okay, now what's going to happen to him? Well, let's look. To go from 30 to 40, we went up. So what do we expect to go here? We expect to go down, don't we? So we'll look at our formula. 40 times 3 equals 120, so we would say that's 3. Okay, this is inverse variation. As the speed goes down, the time goes up. As the speed goes up, the time goes down. They are inversely related to each other. Okay? So that's what that means. I'm going to give you a quick example. The area of a rectangle is 24. Okay? So we're going to do length and width. So I'm going to say the length is 8 and the width is 3. I want you to come up with another rectangle where the area would be 24. Okay? So what if I pick this? What if I went up in my length? If I went up in my length, what do I expect to do with my width if I still want the area to be 24? Well, my formula for this is area equals length times width, right? So we're doing length times width equals length times width. This is 24 equals 12 times what? That's 12 times 2. Makes sense, right? This goes up, that goes down. That is inverse variation. So I told you I would give you an example. Let me give you an example like we did the last one. Assume x varies inversely as y. If x equals 4, when y equals 6, find y when x equals 12. Okay, remember, here's your formula. X times y equals x times y. I'll give you a minute. I'll give you a minute to do that. I have confidence, lots of confidence. Not misplaced. No, it's not misplaced. No. Lots of confidence. So it says they're inversely related, so there's my formula. 4 times 6 equals, we kind of just did this, 12 times y. 4 times 6 is 24, equals 12y, so it looks like y is 2, okay? All right.